So next we want to think about the relationship between the voltage and the current. We find that if we attach a voltage across a conductor, the current is proportional to the voltage. So the larger the voltage, the larger the current. If we graph the current as a function of the voltage, we find a straight line, and the proportionality constant is the resistance. So the resistance is a measure of how difficult it is for current to flow through a conductor. So the larger the resistance, the lower the current, and the lower the resistance, the larger the current. The resistance is inversely proportional to the current. So we could also use a measure of how easy it is for a current to flow through a conductor, the conductance, but we do not normally use the conductance. So conductance is 1 divided by the resistance, but generally we will use resistance, which is your measure of how difficult it is for the current to flow. So the big advantage of the resistance is that this sets up Ohm's law, which is a very simple description of the relationship between the voltage, the current, and the resistance. Ohm's law is the voltage across the conductor is equal to the current I times the resistance R. That means if we need to know the resistance, we can divide the voltage by the current to get the resistance. If we want the voltage, we can multiply the current by the resistance, and if we want the current, we can divide the voltage by the resistance. So if we have 2, then we can solve for the third easily. The resistance comes from the fact that as the electrons flow through a wire, they collide with other electrons, but they also collide with the nucleus of the atoms and cause vibrations in the conductor. These vibrations are basically heat, and so the internal motion of the conductor increases, and that means it's getting hotter and goes to a higher temperature. So if we want to understand what the resistance of a particular conductor is, we need to know the resistivity of the material and the size of the wire. So the resistance is equal to the resistivity of the material times the length and divided by the cross-sectional area. If we are imagining pushing our electrons through a tube, like viscous liquid like toothpaste, then the longer the tube, the more difficult it will be, whereas if you make the tube wider, it will be easier to push the toothpaste through the tube. So resistance works exactly the same way, and if we divide the resistance of a wire by the length and multiply by the area, that gives us our resistivity, which is this rho symbol, which is kind of a funny looking letter P. And it depends on the material, with a good conductor like copper or silver having an extremely low resistivity, something like iron that's a pretty good conductor but not a great one, maybe 10 times larger, and then if something's an insulator, it's maybe 10 to the 6, 10 to the 7 times larger. So if we doubled the length of our wire, then the resistance will double if everything else is kept the same. If we doubled the surface area, then the resistance will be cut in half. Notice that means if we double the length of the wire, then the current will decrease because the resistance is doubled. If we double the surface area, then the current will double, assuming the voltage is kept the same. A useful analogy is with the flow of water through a straw. For example, when you were a kid, you might have taken multiple straws and connected them in order to drink your soda. So if you did that, you would notice that as you added more and more straws, you'd have to suck much harder in order to drink your drink. So the longer the straw, the larger the resistance. On the other hand, maybe you got one of those coffee stirrers that is like a very thin straw instead of a regular straw, and then you tried to drink. If you did that, you noticed that you had to suck extremely hard in order to get anything to come out. So if you decrease the cross-sectional area of the straw, then your resistance increases. All right, so next we're going to talk about electrical energy. So we'll have a question here.